This video is over Lesson 1 for Module 3 in Grade 7 on Eureka Math Squared. It is over equivalent expressions. In these first few problems, we're going to determine if the expressions are equivalent based on a couple of things, either combining like terms or using the distributive property. Okay, so if they are equivalent, state the property of operations or reasoning that justifies why the two expressions are equivalent. And if they're not equivalent, choose a number for the variable and use that number to evaluate each expression and explain why they're not equivalent. Okay, so looking at our first problem here, number 1, 10 minus 10 plus 3x. And then we have a second expression, 3x. Okay. So as we're looking at this, okay, we can go ahead and combine our like terms here. Okay. What we really want to do is we want to kind of, remember, remove that minus. We want to rewrite this as 10 plus negative 10 plus 3x. That way we get rid of the subtraction. Okay. And now we notice that 10 and negative 10 are additive inverses. And when you add additive inverses, you get 0. And anything plus 0 is simply itself. So I have 3x and I have 3x. Okay? So these are equivalent. Okay? And the reason why, okay, is based upon the fact that we have the additive inverses. The 10 and negative 10, okay, which add up to 0, which gives us 3x for both expressions. Okay. Number 2, I have x plus 3x, x plus 3y plus z, and 3y plus x plus z. Determine if they are equivalent. Okay. Each of these has one variable term, or one variable term for each. I have 1x, a 3y, and a z. And if you look, it's the same thing here. The only difference is that we switched the order of the x and 3y. Okay. When we use addition properties, we can reorder our expressions in any way as long as we have all of the same operation symbols. Okay, so we could say these are equivalent based on the commutative property of addition. Okay. If we said this was 1, 2, and 3, well, 1 plus 3 times 2 is 6. So 1 plus 6 plus 3 would give me 10. Well, if I had 6 plus 3 plus 6 plus 1 plus 3, that's also 10. So no matter how I add them, it would give me 10. So they are equivalent expressions. And we know they're equivalent because we did a reorder of the terms, which is able to be done based on the commutative property of addition. The commutative property, okay, says you can reorder the expression. Next question, number 3. I've got like terms I can combine here. This x is 1x. Okay. And 1x plus 4x is 5x. So I have 3 plus 5x. Okay. And we know that you cannot combine unlike terms. So 8x and 3 plus 5x are not the same. if we substituted in a number, let's just say we substitute 0 in for x. Okay. Well, 3 plus 0 plus 4 times 0, well, that's 3 plus 0 plus 0, and that is equivalent to 3. 8x would be 8 times 0, which is 0. And these are not equivalent, so the expressions themselves are not equivalent. On to the next question, number 4. 3x plus 2 and 3 times the quantity, the sum, x plus 2, and 3x plus 6. Well, when you see parentheses, that says to multiply. If you have a term out front of parentheses, you're multiplying that term times each term inside the parentheses. So I'm going to take 3 times x, which is 3x, plus 3 times 2, which is 6, okay, which is exactly what we have here in this expression. So we would say that they are equivalent, okay, because of the distributive property. So there's your distributive property. Okay. Number 5 looks a little different than because we have parentheses, but with no term out front. Okay. Again, if we do order of operations that says we need to solve parentheses first, well, we can't do anything here because these are not like terms. So then if we drop the parentheses, that gives me 8x minus 9z. If I follow order of operations here, this says 5x plus 3x, which is 8x, minus 9z. And we can't combine the x's and z's because they're not like terms. Well, this is the exact same expression. So these are equivalent expressions. Okay, and they are equivalent, okay, by the associative property. The associative property says you can group, any set of numbers. Okay. In this one, I grouped the 3x and the negative 9z. In this equation, or this expression, I grouped the 5x and 3x. Okay. Usually we do this to make it easier to solve or to have like terms together grouped. Okay. Number 6. Okay. If I am looking at this, I'm going to combine my like terms. Well, 3x plus 2x equals 5x minus 7. Well, we have 5x minus 7 here. Those are the same. These are equivalent. Okay. And they're equivalent because when you combine like terms, I get the same expression for both. Okay. And combining like terms is kind of like distributing. You're distributing that x to both terms and combining those. Okay. We're going to use the distributive property here next. Okay. Multiplying 2 times x gives me 2x minus Oh, we're looking like we have equivalent expressions so far. 2x minus, and we've got 2 times 2, which is 4. Well, 2x minus 4 and 2x minus 2, those are not the same. Okay, so these are not equivalent. Okay, not equivalent. So if I put 0 in for both of these, okay, so 2x minus 2, I put 2 times 0 minus 2, that's 0 minus 2, which is negative 2. Okay. If I use 2 times 0 minus 2, well, I get 2 times negative 2, which is negative 4. And negative 2 and negative 4 are not equivalent. And when we substitute different numbers in, we do not get the same expression. Number 4, it's got a little bit of distributive property here. 5 times 4x is 20x plus 5 times 1, which is 5, plus 3x. Okay. Well, if we reorder these, I have 20x. If I rewrite the 3x at the 5, that's your commutative property right there. And 20x plus 3x is 23x plus 5. And 23x plus 5, 5 plus 23x, these are just written in opposite order of each other. So that would give me a commutative property in terms of rewriting this. So you would say equivalent expressions, okay, by using the distributive and commutative properties. Sure, and commutative property, and this is the commutative property of addition. Okay, we reordered the addition. Right, and here we go, we have 4x plus 36, that's already simplified. So here we're going to distribute 10 plus 4x plus 36. That minus 10 becomes plus negative 10. If we reorder, okay, and we group our inverses together, that equals 0. So 4x plus 36, which is the same for both. Okay. So we would say equivalent. Okay, and we used the distributive property. The distributive property, additive inverses, and the commutative property of addition. So these are all ways, these are all examples showing that we have equivalent or not equivalent expressions. Okay, using those properties that we've previously learned. On the next page, we have Logan saying that 2 times x plus 4 must be equivalent to 5x plus 8 because he tested 0 and it worked. Is Logan correct? Okay, and we need to explain why we say that it is correct or not correct. Okay. So, looking at this, Logan is not correct. Okay, the answer to this question is no. Okay, Logan is not correct. Okay. If we go through here and distribute, just for instance, okay, so 2 times the sum of x and 4. We're going to distribute this 2. So 2 times x plus 2 times 4, which is 8. Okay, and 5x plus 8 is not the same as 2x plus 8. Okay, they are not equal. Okay. We could also use a different number to test. Let's say that we used 1 here. So I said 2 times 1 plus 4. Well, 1 plus 4 is 5, and 2 times 5 is 10. If I used 1 in the second expression, I have 5 plus 8, which is 13. Okay. When you're looking to see if expressions are equivalent, you're not just going to use numbers to test out. You need to go through and use your properties: distributive property, commutative property, associative property, additive inverses, etc., and simplify these expressions. Okay. By doing that, you would see that 2x is not the same as 5x. Okay. Or by possibly testing more than one number. Okay. On the first 9 problems, also that were not, we showed how we got those numbers, and then we used 0 to check. Number 11, Lily says 12x divided by x equals 12, but Maya says that is not always true. Who is correct? Explain your reasoning. Okay. In most cases, Lily would be correct. Okay, but Maya is actually correct because it's not always true. If I use 0 for x, okay, you type that in on a calculator, you're going to get an answer that says undefined. So if you have 12 times 0 divided by 0, you're going to get an answer that is undefined. Okay? Or you might get an error message. Okay? Well, that is not equal to 12. Okay? We cannot divide by 0, so therefore Maya would be correct. Okay? Who is correct? Maya is correct. Okay, because you cannot use 0, okay, so the expressions would not be equivalent in that case. Okay, if we use some other numbers, it might work. So for instance, if we used 1, well, 12 times 1 is 12, and 12 divided by 1 is 12, and 12 equals 12. No, that would work, but 0 doesn't work. Okay, therefore, we cannot say it's always true. Okay, Maya would be correct there. Next, okay, for number 12, go ahead and create 2 equivalent expressions, and then one that is not equivalent to the other 2, and see if someone around you can determine which one is the lie.